Let there be light. Music, the moment where space-time and everything else that came into existence which would eventually give rise to the present day. Cosmos occurred some 13.75 billion years ago, the prevailing cosmological model explaining the existence of the observable universe from the earliest known periods is known as the Big Bang Theory. It is one of the best theories we have in all of science, but of course it doesn't explain everything, like why did the Big Bang happen in the first place, but maybe the question why is not a good question, as it presupposes the universe had a purpose. Perhaps a better question is how. The question for a scientist, particularly for physicists and biologists are interested in the fundamentals of life, is how was it, how did it come to be? The Earth is populated by so many wonderfully diverse organisms, and from a physicist perspective you want to go back all the way to the beginning, so this is a picture of the origin and evolution of the universe as we know it now. Now, we made a spectacularly precise measurement of the age of the universe quite recently. Actually, the current number is 13.75 billion years old. So the picture is that 13.75 billion years ago the universe began. Why? We don't know. We don't know the answer to questions such as what happened before the Big Bang. I get asked that a lot. The answer is we don't know. It's out there, it's current research, but we do know that the universe was extremely hot and extremely dense and extremely small 13.75 billion years ago. In fact, everything we can see in the universe today we think at some point was compressed into something, and in fact probably smaller than an atom. So it's a tremendous thought, but what we know is the universe expanded and cooled ever since, and as it cooled, complex things began to, well, initially crystallize out. But it's a strange thought that we know fairly well at the moment is just how precisely we understand how things began to crystallize out, and just from that ball of energy 13.75 billion years ago we get today things like DNA and planets and stars and people. How do you go about finding out? One way is to look up at the stars. The other way is to build machines that can explore the universe by recreating the conditions that were present close to the Big Bang. The idea that the universe began as an unfathomably single point, then expanded and stretched out to grow as large as it is today is truly mind-boggling, but that's what the evidence strongly suggests happened, and just because something is unimaginable to us does not mean it can't be reality. To quote Neil deGrasse Tyson, the universe is under no obligation to make sense to you. Two major scientific discoveries provide strong support for the Big Bang Theory. Hubble's discovery in the 1920s of a relationship between a galaxy's distance from Earth and its speed, and the discovery in the 1960s of cosmic microwave background radiation. When scientists talk about the expanding universe, they mean that it has been increasing in size ever since the Big Bang. But what exactly is getting bigger? Galaxies, stars, planets are getting bigger. Their size is controlled by the strength of the fundamental forces that hold atoms and subatomic particles together. And that hasn't changed. Instead, it's the space between galaxies that's increasing. They're getting further apart as space itself expands. And if that's the case, one might wonder, what is the universe expanding into? The standard answer, as best we know at the moment, is that it doesn't expand into anything because it's space itself, and actually space-time. If you talk to Einstein, that's expanding, so it's not the right picture to think of a Big Bang in a pre-existing space. It's not like that at all. It seems that as far as we know, space and time began at the Big Bang, and they've been stretching ever since, and so it's kind of a related idea is where did the Big Bang happen? You think, well, we're in this big box of the universe. Did it happen over there, or over there? Over there. It happened everywhere, because all the space was made as far as we know at the Big Bang. So the Big Bang happened everywhere, so it's not expanded into anything. It's very difficult to picture that. What I should say is that the theory that deals with this, the underpinnings, called Einstein's theory of general relativity. He wrote it down in 1915, and it's still our best theory of space and time, and the theory upon which all these interesting and strange ideas rest. Extrapolation of the expansion of the universe backwards in time using general relativity yields an infinite density and temperature at a finite time. In the past, in physics, a singularity is an infinitely small space. Within this small space exists infinite gravity and density. In fact, gravity within a singularity is so great that not even light can escape from it. Occurring within a singularity, the Big Bang was the ultimate extreme. Simply put, the entire universe was jammed into An infinitely small space, in turn this gave way to infinite temperatures, density, and pressure. As counterintuitive and strange these ideas may sound, they have a firm theoretical framework. Based on our understanding of the laws of physics, as we alluded before, our natural instincts and senses that evolved in the African savanna have no ability to grasp infinite density, but there are even more bizarre and astonishing ideas than this. Our universe may not be unique. There could be parallel universes out there. Imagine that we're not in this three-dimensional space. Just forget one of the dimensions. So imagine we're on a sheet. So imagine we lived on the surface of a sheet of paper, and imagine the forces of nature, particularly light, traveled on the sheet. And then there's another force called the nuclear force, the strong nuclear force that sticks your atomic nuclei together. Imagine that only works on the sheets as well. And imagine there's another force called the weak nuclear force. Imagine that only works on the sheet. Then what would happen if there were another sheet, another universe, if you like, just floating a millimeter away, let's say? Well, you wouldn't see it because light is confined to your sheet. You wouldn't feel it because the forces don't come off the sheet there, so it could be there now. If that's true, then we can try and do experiments and say, how would we possibly detect it? Not really well known, but there are some signatures of these extra dimensions as they were that you can see at the Large Hadron Collider at CERN. It's a very speculative stuff, so it could be. I find this remarkable that there's another universe a millimeter away from your head in a big sheet, stretching out infinity in all directions, and you just don't perceive it because the forces that are existing exerted on us that hold us together don't travel from one sheet to the next. Of course, it would be extremely difficult, if not impossible, to prove the existence of other universes if they do not interact in any way, shape, or form with our own universe. However, if there comes along a theory that is extremely accurate in describing how our own universe operates, and in addition that theory also predicts the existence of other parallel universes, it will be reasonable to infer the existence of other universes despite the lack of physical data. To a lay person, it may seem that physical cosmology is producing all sorts of stories without any backing of actual data. But that could not be farther from the truth. For example, the Big Bang Theory, although dismissed by Einstein in the 1920s when it was first proposed, later gathered firm ground early in the 20th century. The universe was thought to be static, always the same size, neither expanding nor contracting. But in 1924, astronomer Edwin Hubble used a technique to measure distances to remote objects in the sky. He discovered that the speed in which the astronomical objects move apart is proportional to their distance from each other. In other words, the farther away objects are from Earth, the faster they are moving away from us. This became known as Hubble's law. Hubble's law allowed astronomers to calculate how long ago galaxies started moving apart, which provides an estimate of when the Big Bang occurred and how old the universe is. And then in 1964, the cosmic microwave background radiation was discovered, which is the leftover heat radiation from the Big Bang. So we had irrefutable physical evidence to suggest the Big Bang happened. Since then, theoretical physicists have described in great detail the evolution of the universe from its very first moments after the Big Bang. It was also found that the expansion of our universe is accelerating, but the cause of it remains unknown, and we will explore the possible answers in another video. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this. Music.